Hi. In this video, we would like to introduce the read-write splitting feature for OpenSearch clusters created in Huawei Cloud's Cloud Search service. This walkthrough has three parts. OpenSearch serves as a core data search and analytics engine for many applications, supporting the growing demands for business data processing. Most enterprises use a single cluster to handle both data write and query requests, which usually works well in the beginning. However, as business expands and data volumes and access requests grow exponentially, such a monolithic architecture faces three typical challenges. First, resource contention. Writes and queries share compute and storage resources. Intensive writes can degrade query performance, while complex queries may slow down writes. Second, stability risks. A sudden spike in query load can overwhelm the cluster, which can even lead to write failures. Third, poor scalability. The monolithic architecture cannot be scaled efficiently to meet changing demand. It's impossible to cost-effectively boost specific capabilities like query throughput or write capacity independently. To address these challenges, Huawei Cloud CSS introduces read-write splitting among OpenSearch clusters. The read-write splitting architecture offers the following benefits. Decoupled workloads. Write and query workloads are handled by physically separate clusters. This isolation prevents mutual interference, ensuring that intensive data ingestion does not impact query performance and vice versa. Targeted optimization. The write cluster focuses on high-throughput data processing, while the query cluster focuses on complex computations. Flexible scalability. The write and query clusters can be scaled independently based on specific load conditions. This allows for more precise, cost-effective resource allocation. This novel architecture overcomes the limitations of monolithic designs, empowering enterprises to build OpenSearch clusters that deliver high concurrency, high stability, and flexible scalability. This ensures reliable performance even under the most demanding data loads. OpenSearch read-write splitting works by having leader and follower clusters collaborate together. The feature delivers the following benefits. Decoupled read and write workloads. The leader cluster ensures data ingestion performance. The follower clusters deliver scalable, high concurrency query performance. There is no more resource contention. Peak loads are reduced. Elastic scalability. Independent horizontal scaling. The write and query clusters can be scaled independently. Cross-region cluster deployment is supported. Data consistency guarantee. Data can be synchronized in real time with low latency. File-level incremental synchronization is supported. This is how read-write splitting works. First, data writes. Users send write requests, and the leader cluster handles these requests. Then, data synchronization. Primary shard synchronization. The follower cluster periodically synchronizes incremental data changes from the primary shards in the leader cluster. Replica shard synchronization. And the follower cluster, replica shards synchronize data from primary shards, enabling distributed replicas. Finally, query processing. Users send query requests. The follower cluster handles these requests and returns the results. Procedure for configuring read-write splitting between OpenSearch clusters. Step 1. Log in to the CSS Management Console. Step 2. Select the follower OpenSearch cluster. Step 3. Log into the OpenSearch dashboards of the follower cluster and go to the DevTools page. Step 4. Configure the leader cluster's information to connect the follower cluster to it. Step 5. Configure index synchronization in the follower cluster by specifying individual index names or using patterns to match multiple indexes. Step 6. If there are multiple follower clusters, configure the leader cluster's information and index synchronization settings for each of them. Step 7. Verify the configuration. For example, if new data written to the leader cluster can immediately be queried in the follower cluster, the configuration is successful. We hope you find this video helpful. You can visit our Help Center to learn more.